here's another one that I've kind of had some questions on, the bond energies. This is what you guys worked on the other day with the purple sheets that we had on the tables. We did them together on the board. So I'm going to look here at number 24. It says calculate your change in enthalpy. And so on this side, it's the amount of energy that we have to break these bonds. Okay, so how much energy is going to have to go into this side to break the bonds. And then on this side, your product side, it's going to be how much energy was used to form those bonds. Okay, and so it's just a little bit different way of thinking about it. But we're going to have to break these guys to form this. And so we're going to look at the energies involved in that. And so for CH4 here, let me try to get this going. You're going to want your, you're going to want your shapes unless you're really good at knowing what these look like. Okay, so I'm going to just draw the shapes over here. So CH4, I have 4 HCs. Okay, so I come over here and I see HC is 413 kilojoules, and you've got 4 of those. So we're going to have to multiply that together. Okay, also on the reactant side, you've got 2O2. So like I said, why you want to draw them out is you may remember that oxygen is going to be double bonded. Okay, that comes back to those molecular shapes. And this thing tells us we have 2 O2. So you have 2 O2s. So O double bonded with itself. So 495 kilojoules. Sorry, my writing's not so fabulous here. All right, so on the reactant side, I'm going to pull up the calculator for a second. Sorry. Maybe. All right, so on the reactant side, we have 4 times 413. And then we have, move my calculator for a second, 2 of the 495s. Okay, so for the reactant side of this equation, we had 2642 kilojoules. That's how much energy it requires to break these bonds. All right, on the product side, you get CO2, and CO2 is another lovely double bonded situation. So you've got 2 of the CO bonds. So I come over here and see CO is 799 kilojoules, and remember you need 2 of them. Okay, and then the last thing, you have 2 H2Os. So you've got this. All right, and you've got this. So if we take a look, I've got 1, 2, 3, and 4 of the HO bonds. So I find HO and I got 463 kilojoules. All right, let's check and see what this product side has here. So I'm going to pull the calculator back up for a second. All right, so we've got 799 times 2 plus 4 times 463, right parenthesis, equals. Okay, so on my product side, I have 3450 kilojoules is the amount of energy that we've got on this product side. So I'm going to subtract the 2, and so I get, find that calculator again, 2642 minus 3450. And I get negative 808. So a couple things. This is my change in H, my change in enthalpy, and also it's exothermic because your change in H is negative.